5, we talk about functions and relations. So first exercise is talk about set notations as set of numbers. In year 10, we talk about sets in probability. So what is set? Set is a collection of objects. So for example, 1, 2, 3, 7 is a collection of numbers. Collection of 100, which is collection of one number, is also a set. And it not only can collect numbers, it can also collect colors, white, black, blue, like that's a set of colors. And can also put descriptions inside. It's a collection of all the odd numbers because it's infinite many numbers inside, so I can use description to talk about the set. And I can say 1, 2, 3, 4, 5, dot, dot, dot. You know that's talk about all the nature numbers for the set. But remember 1, 2, 3, like just write like that is not a set. To be a set, like this curly bracket is very important. You have this curly bracket, it means your collection of those elements, and that is a set. So next one is element. So what is element? Basically, the objects in the set are known as element. Okay, everything you write inside is element. Okay, for the first set, I have 1, 2, 3, 7. There are 4 elements in the set. For the odd numbers, which I have all the odd numbers, which is infinite many elements in the set. Curly bracket is necessary for a set. If you don't have the curly bracket, it's not a set. We use comma in between all the elements. Okay, so the next one is belong. This is belongs to and not belongs to. If X is an element in the set A, we write X belongs to A. So for example, we write 2 belongs to 1, 2, 3, 7. So we read it as X is a member of set A, or X belongs to set A, or X is in the set A. But one thing important is this 2 is an element. And this is a set. So what we can see is this is used to describe the relationship between an element and the set. So left-hand side must be an element, right-hand side must be a set. Okay, so you cannot have set and set on both sides and use this sign. So this symbol only connects elements and set together. And 2 is not belongs to the odd numbers because 2 is even number, is not belongs to the set, so it's not belongs to. And the next 2 symbols are really similar to this one, which is contains and not contains. So if B is a subset of A, so which means all the elements in B also in A. Okay, all the elements in B and also in A. So which means B is a subset of A. For example, if I have set B equals to 1, 2, 3, 4, set A equals to 1, 2, 3, 5. Okay, 1, 2, 3 is in set A, but 4 is not in set A. So B is not a subset of A. Okay, B is not a subset of A because B got one element which not belongs to A. So we use this one, for example, talk about 1 and 3 will be the subset of those odd number sets. And 1, 2, 3 is entirely equivalent to the 1, 2, 3, so I can also say that's a subset. Subset can be less than or totally like equals to that the right hand side says. So B is not a subset of A. We write B not contain A. For example, 1 to 4 is not a subset of odd numbers, so we use the symbol not contains. So for those 2 symbols, we use to describe relationship between set and set. Okay, we are talking about 2 sets. We use those 2 symbols to connect them. So there are 4 symbols. When you want to choose one of that, you must think about, is that a relationship between element or set and a set and a set? Okay, so we need to think about to choose between those 4 elements. Okay, number 5. This symbol is an empty set. Okay, empty set. So what is an empty set? Empty set means there's nothing inside, even not 0 inside, okay? If you have 0 in the set, it means the set contains 0. But like empty set means there's nothing in the set, so we just have this 2 curly bracket, and that represent empty set. But like, you know, like it looks really weird if you have a empty curly bracket, so we give a symbol to this. We use the circle and a line to say this is an empty set, okay? To say this is empty set. So for this one, it can represent a set and it's not contain curly brackets. Okay, so this is a symbol to talk about this is a set. Okay, so it's an empty set. And next one is intersections. Intersection have this n, like n symbol. So the set elements common to both set A and B is called the intersection between A and B. So the elements needs to be in A, and the elements also needs to be in set B. So for example, we read a set intersects with another set. We see the common part. We can see 1, we can see 5. So 1 and 5 will be the new set. The thing is, must be a set intersects with a set, and the result must be a set as well. Okay, set intersects sets give you sets. So A intersects B. We can use a set notation. This is called a set notation to talk about. Okay, I'll explain the set notation. It's quite important. A intersects B equals to, okay, the whole thing here. What this set means? It means a collection of elements X. Okay, it's a collection of elements X and have dot dot. What after this dot, it's explaining what's happening. Okay, explain to you what is this X. Okay, I'll explain that the X will belongs to A and also X belongs to B. Okay, so that is a set notation. It talks about, like this is a collection of all the elements X, but what is X? X belongs to A and X also belongs to B. So this is use mathematical notation to talk about like things instead of talking about things in words. Okay, so we use that set to talk about, that's a set notation for A intersects B. So for intersections must be two sets, connect by the intersection sign, and the result must be intersection. Similarly, we have, we'll talk about disjoint first. So what is disjoint? Disjoint means there's nothing in common in between A and B. Okay, what is disjoint? If two sets intersection equals to an empty set, which means there's no elements in common, then this is a disjoint set. Okay, A and B are disjoint. For example, if we have A equals to 1, 2, 3, and B equals to 4, 5, 7, nothing in common, then A intersects B will equals to empty set. Okay, nothing here. And then we will say A and B are disjoint. Okay, A and B are disjoint. Next one is similarly to intersection, which is union set. Union set use a U. Okay, U symbol, so U means union. So intersect means this and this, so we use an N. So union is U, and it means the elements either in A or in B. So basically you just write every element in A and in B in the order. Remember, if you have 2 in set A and 2 in set B, you are not going to write this 2 twice. Okay, each element only appears once. Okay, I don't care about how many times it appears. I just want to see which element is in the set. So if you have repeated terms, we will write it only once. Okay, so for example, we have 1, 2, 3 union 1, 4, 5. 1 is repeated, but doesn't matter. We still just write 1. And so we have 1, 2, 3 and 4, 5. Okay, the union set is that. And the last one is talk about set difference. Okay, so what is set difference? Set differences means, okay, if it's A, order is important. A set difference with B means the elements in A but not in B. Okay, what is in the front means the elements in that set. What at the back means I will exclude the elements in that set. So it's in A but not in B. So the set in A, we can use this one to explain that. It's a collection of X such that X is the element of A, but X is not element of B. So we find about like what is in A, but not in B. So for example, 1, 3, 5, set difference with 1, 4. So 1 is in set A, but it's also in set B. So A is not the correct one. So 3 is in set A, but not in set B. Okay, 3 will be one element. 5 is in A, but not in B. So 5 will be one element. So 3, 5 will be the result. Okay, 3, 5 will be the result. Okay, so let's talk about set difference. Set difference is very important because we use it a lot when we talk about domain and range. Okay, set difference is important. You must understand what the set difference means. Okay, my question is, okay, I'll give you 1 minute to complete question 1. Okay, 1 minute to complete question 1. So you just choose belongs, not belongs, contains, not contains to talk about the relationship between those 6 things. Okay. 1 minute. Everyone is to two things. If you don't have notes, you can see it here and make it bigger. Okay, you want to choose between that. You will think about, is that an element a set or a set and set? Are we talking about relationship between an element and set or set and set? It's very easy to make mistake. Curly bracket 3. Okay, remember curly bracket 3 is talking about a set. Okay, it's a set. Yeah, the curly bracket is an indication of whether this is a set or not. So for curly bracket 3, is that a set? Yes or no? Yes. So curly bracket 3 is a set. So we have set here. A is a set. So we have set here. If we talk about relationship between two sets, can we use belongs or not belongs to? We cannot use that. What we can choose is only contained or not contained. Is that set a subset of A? So A contains 1, 2, 3, 7, and 3 is the element in A. So that is a contained. Okay, it's not a belongs to. So that's the. Okay, at least 2/3 of you make mistake in this question. Okay, so we are not using the belongs to because it's talking about relationship between two sets. Okay, and for the next one, A and B. A is a set, B is a set, so we will choose between contained and not contained. So in set A, we have 1, 2, 3, 7, but 1 is not in B. Okay, 1 is not in B. 2 is not in B. 3 is in B, 7 is in B, but doesn't matter. We have elements not belongs to B. So this will be not contained. Okay, we use not contained. For B and A, so same thing. We have set and set. In set B, okay, 3 in A, 4 not in A, 5 not in A, 6 not in A. So we have elements not belongs to A. So it's a not contained relationship. Okay, B is not a subset of A. 3 and B. Okay, 3 without curly bracket. It must be an element. B is a set. We talk about relationship between element and set. So we use belongs to or not belongs to. Okay, 3 is in set B, so we use belongs to. Okay, we use this E. Okay, 1, 3, 7 is a set with curly bracket, and B is a set. So 1, 3, 7. Okay, 1 is not in set B. 3 is in set B, 7 is in set B, but 1 is not in, so it's not a subset of B. So we use not contained. Okay, we use not contained. Okay, 5 and A. 5 is an element, A is a set. We talk about element and set. Okay, element and set, we use belongs to or not belongs to. Okay, 5 is not in A. Okay, 5 is not in A. So 5 is not element, we use E and with the slash. So not belongs to. Okay, not belongs to. Okay, find the following. Give you another minute to finish this one. So A intersects B, A union B, A set difference of B, and B set difference of A. Okay, when you finish, you can draw this Venn diagram on your notes. So it's talk about in a Venn diagram, what each part represents. Okay, what each part represents. So in the middle, it must be A intersects B, which is the common elements. Okay, on the left hand side, if that set is A, which means it's A set difference of B. Because those elements only in A, but not in B. Okay, the one already in B have excluded that out. So for the right hand side, it will be B set difference of A, because that's seen in B and the part in A has been excluded in the intersection part. And for the whole two circle combined together, that's A union B. Okay, so two set union together, so every element in those sets. And for the last thing is all the outside part, which I can say that A intersects B, A dash intersects B dash, or I can say that is A union B dash. Okay, two kinds of notations, which basically means haven't include everything. Okay, I haven't include everything, so I have exclude all the things in A union B, so everything except that. Okay, so what has been left is A union B dash, or A dash intersects B dash. Two notations for that. Okay. So let's come to find the following thing. We have A intersects B. So A intersects B will be the elements in A and also in B. And remember, your result must be in curly bracket. I haven't looked through, but how many of you haven't put things in curly bracket? It must got answers in curly bracket. It's a set. Okay, represent is a set. So in A and in B. Okay, 1 is not in both, 2 is not in both, 3 is in both, and 7 is in both. So A intersects B will be 3 and 7. A union B means what you can see and you write them all in this set. Okay, A union B. In A we have 1, 2, 3, 7. And in B we have 3, 4, 5, 6, 7. So we have 1, 2, 3, 4, 5, 6, and 7. Okay, it's a set contain 1, 2, 3, 4, 5, 6, 7. Okay, it's a set include everything. Okay, it's a set include everything. Okay, the next one is A set difference with B. So in A but not in B. So what is in A? 1 is in A but not in B, so 1 will be alright. 2 is in A but not in B, 2 is alright. 3 is in A but also in B, 3 is not good. 7 is in A but also in B, 7 is not good. So we have 1 and 2. For B set difference of A, okay, so what means B set difference of A? Which means in B but not in A. 3 is in B but also in A, not good. 4 is in B but not in A, 4 is good. 5 is in B but not in A, 5 is good. 6 in B but not in A, 6 good. 7 in B but also in A, 7 is not good. So I have 4, 6, 7 for B set difference of A. Okay, so that should be the answer for intersection union set difference. Okay, now come to talk about set of numbers. We have some number sets. For example, we talk about natural numbers. We talk about all the integers. We talk about all the real numbers. We talk about rational numbers. So when we talk about those things, we give them a name. Okay, we use a letter to represent that. We don't want to write a whole long set to represent that. So we give that a letter. When you see that particular letter, you know what numbers I'm talking about. So for the first one we talk about is natural numbers. We use an n to represent natural numbers. So natural number include 1, 2, 3, 4, 5, 6, ... but not including 0. Okay, in natural numbers there's no 0. Okay, so not including 0 in natural numbers. Okay, when you see the letter n, there's no zeros inside. Okay, next one, integer. Integer use z. So it include negative integer and also positive integer. Okay, -3, -2, -1, 0, 1, 2, 3, 4. In integers, 0 is included in. Okay, 0 is included in integers. You can see the 0 here. And we talk about all the integers, so there will be infinite many numbers inside the set. Okay, the next one we use a z plus to represent all the positive side of numbers, integers. So which means 1, 2, 3, 4, 5, 6, 7, which is equivalent to natural numbers. So if you say n, that will be equivalent to z plus. They are exactly the same. Okay, natural number will be exactly the same as z plus. Okay, negative integers. Okay, all the -1, -2, -3, -4, all the way to left, but not including 0. Okay, when we talk about positive or negative numbers, 0 is not positive or negative. So when you talk about positive integer and negative integer, you are not talking about zeros. Okay, no zeros included. Okay, there's a small question here. Is z plus union z minus is the entire z set? Is that z plus union z minus will give you the whole z? Is that correct? Is that statement correct? Yes? No, I see no, I see yes. No, why no? Okay, it doesn't include 0 in this left hand side. Okay, no zeros. But have 0 in the set. Okay, we're missing one number in left hand side, so this is a wrong statement, incorrect. Okay, this is incorrect. Z plus union Z minus is not including 0, but Z includes 0. Okay, Z includes 0. Okay, next one is rational numbers. Next one is rational numbers. So what is rational numbers? What is rational numbers? You keep learning this from year 9, okay, until now. So rational numbers, we use Q to represent that. Okay, Q means rational numbers. I write a set P on Q. It's lowercase p over lowercase q. So what is rational numbers? If a number can be written in the form of fraction, it is a rational number. Okay, any number it can be represented in the fraction form, that will be a rational number. So three main types. Okay, three main types. The first type will be integers. Okay, why integers work? For example, 2. 2 can be written in the fraction form of 2 over 1. Okay, that is in the fraction form, which makes sense. Okay, 2 over 1. The next one is terminating decimal numbers. So what is terminating? We have a finite number of decimals. So for example, let's say 1.7234. So it can be written as 234 over that. Okay, 17234 over 10,000. That can be written in the fraction form. Okay, you just make the top as whole numbers and divide like how many decimals you need to move. You put how many zeros after 1. You divide by that. That will be exactly the same as this one. So all the terminating decimal numbers can be written as fraction form. So that will be rational numbers. Okay. And the last type will be circulating decimals. So there will be infinitely many decimals, but like it's circulating. For example, let's say we have 0.742, like it's circulating all the way back. So we can write that into fraction form for sure. Okay, if you want me to prove that for you, okay, I will make assumption like this. Let's say I just give you one example. You can think about how to deal with the others. You know that 0.33333, that is equals to 103, right? You know that. So that's the easy one to think about. But how we can make 0.724724 become fractions? Let's say x equals to that. Okay, x represent that number. Okay, how about 1000x? What 1000x equals to? 1000x will equals to 742.742.742 ... right? We still have 742 as my decimals. Okay, I'll subtract equation 2 from equation 1 from equation 2. So I will have left hand side have 999x, and right hand side I will only left with 742. All the decimals can be cancelled out. Can you see that? All the decimals repeating, and it's all the same for 1000x and x. Okay, subtract both equations. I have 999x equals to an integer number. So what x equivalent to? X equivalent to 742 over 999. And what that means? That means x equals to that. And what is your x? X equals to 0.742742. So 0.742 circulating 7 and 2 will equivalent to 742 over 999. Okay, so all these circulating decimal numbers can be represented by this way. Okay, it all can come back to do by this way. Okay, can check. If you want to check, you can check. That must be the same. Okay. So we use, okay, because it's like 3 decimal places circulating, so 742 is 3 numbers circulating. So I will times this x by 1000. I'll times this x by 1000. If it's 2 numbers circulating, for example, 0.23232323, I will times that by 100, become 23.232323. If it's 4 numbers circulating, 123, 123, 123, I'll times this by 10,000, like by 10,000, and to increase that and become 1234.1234. So how many numbers it's circulating? You put times 1 and that much zeros at the front. Okay, 1 and that much zeros in the front to increase that by that much decimals. So you have a whole number part and you have exactly same decimals at the back. So, and you can subtract between the 2 fractions. You have integer number and integer numbers on both sides, and you divide, you have x equivalent to that fraction. So I just want to show you don't really need to know how to do this. If you learn further, I think some part in further will have the similar things. But if you're not learning further, like you just need to know circulating decimal numbers will become rational numbers. Okay, I've just proved that to you. Okay, so that's main 3 types of rational numbers: integer, circulating decimal, and terminating decimals. And the next one is talk about irrational numbers. So what are irrational numbers? Irrational numbers is that the number cannot put into the fraction form. So basically there's one type which cannot put into fraction form, which is infinite recurring decimal number. So pi. Okay, 3.14 blah 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 blah, like it's not repeating and it's really random. Those numbers cannot become rational numbers. It's irrational. We say pi, but pi is not a number. You know that pi is the symbol to represent that number. So it's not in the fraction form. Not say pi over 1. Okay, please do not say pi over 1 to me. It's not in the fraction form. Pi is the symbol. So pi is irrational numbers, and also any third will be irrational number. Not any third, is the third cannot be simplified, will be irrational numbers. For example, square root 4 will become 2. That is rational. Okay, that is rational. Can be simplified. But like say square root 8, that will become 2 root 2, which you still have the third. Okay, the square root there. So it's a rational number for this one. So, and also if you learn later, you will know the natural number e. Okay, the natural number e. You have an e, you can see on your calculator there will be an e sign. Okay, so represent natural numbers. Natural number is 2.7. Okay, about 2.7. I can't remember the rest decimals, but it's about 2.7. But it's same as pi, all the numbers without patterns. Okay, just random. So those three things are really typical type of like irrational numbers. Any third, for example, cube root of 2, that's irrational as well. Okay, that's irrational as well. So any third is irrational if it cannot be simplified. Okay, so we use q dash to represent irrational. Because rational is q, then q dash is the complementary set, which is irrational. Okay, q and q dash. Next one is real numbers. We use r to represent real numbers. So every number basically. Okay, on the number line, every number is real number. If you learn Spanish, you know complex numbers, like which is imaginary numbers, they are not including in the R set. We have IM to talk about imaginary numbers, but we use R to represent real numbers. Okay, all the things you can see on the number line, what you have learned so far, they are all real numbers. You have R plus and R minus to represent all the positive real numbers and all the negative real numbers. If I can represent on the number line, that will be all the numbers here, but not including 0. And if you use negative R, that will be all the things to the left and not including 0. Okay. Next one is R plus union R minus equivalent to the entire R set. Is that correct or not? No, okay, everyone knows this time. So it's incorrect. It's not including 0. No zeros. And half zeros. Okay, so we have those symbols. So let's think about what we have. We have real numbers. Okay, we have real numbers. In real number, it basically can be two things. We have rational and irrational numbers. Okay, under the rational numbers, what we have z. Okay, we have z. The integer numbers. Integer numbers can be put into two things. Can be z plus or z minus. So z plus will be equivalent to natural numbers. Okay, z plus will be equivalent to natural numbers. So that's the relationship between all those sets. And we also can put that into the Venn diagram. We have Q as the, like R as the whole set. Okay, see this R is everything. In R we have Q and Q dash. Okay, in R we have Q and Q dash. And then we have Q, inside Q we have Z. Inside Z we have N. Okay, that's the relationship I'm talking about. And it's same as this chart. Okay, same as this. Okay, now come to a really important part. Okay, it's the last thing I'm talking about today. So it's the notation. So what is notation? The notation is talk about X such that blah 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 is donated by the set. So it's a kind of notation thing. Let's directly look at this example. We have the set. It's a collection of X. You know it's a collection of X. Such that X is in between 0 and 1. So this set is talking about some number in between 0 and 1, not including 0 and not including 1. But why we are not listing them out? I cannot. Okay? In between 0 and 1, there are rational numbers and irrational numbers. I cannot represent. There are all the numbers that have infinitely many numbers in between 0 and 1. So I cannot really list them out. So I will use this notation to talk about that. It's a collection of X such that x needs to be in between 0 and 1. Okay? And we can say, we talk about the next one is you need to know how to read set. Okay? You need to know how to read set. So for this one, we have x, collection of x, such that I'm collection what numbers? Explaining. I want numbers x greater than 0. I want all the number greater than 0. But I have another requirement with comma, x is rational numbers. Okay, I want all the positive rational numbers. It's a collection of all the positive rational numbers. Basically, I can say that. If I can use word to explain, so this set will be equivalent to that. And the next one, I will have a collection of 2n. And what n means? N can be 0, 1, 2, 3, 4, 5, 6. A natural number and including and plus 0. So what are the numbers? It's actually all the odd numbers. Okay, it's all the odd numbers. 0, 1, 0, 2, 4, 6, 8 if you sub 0 in. So it's a collection of even numbers, not odd. Even numbers. Okay, it's a collection of even numbers. 0, positive. Okay, I'll say positive. I can't say positive because I say positive means not including 0. So what I can say is non-negative even numbers. Okay, non-negative even numbers. Non-negative means I can't have negative, but I can have 0. So non-negative even numbers. So which means this set. Okay, so because we have this, you can see if I want to talk about numbers in between 0 and 1, all of those numbers, it's very long. I need to use x such that x is in between 0 and 1. It's a really long notation. I try to simplify things down. Okay, I want to simplify the difficulty level of write things. So I will go to intervals. Okay, interval is set. Okay, so interval is a set. It's a short notation for set. Okay, it's a short notation for set. So what that means? Okay, so what I have brackets. We use brackets to talk about I start from which number and I finish at which number. I use bracket. I have two types of bracket. I have round bracket and I have curly bracket. And I also can mix with those brackets. Okay, I can have 4 types of brackets. I can 2 round, 2 square, 1 square, 1 round, 1 round, 1 square. Okay, I'm talking about like the set notation. So from which number until which number. So to the left hand side must be the smallest number. The right hand side must be the largest number you want to reach. And this side, this square bracket means include. So those 2 endpoints can be included in. For example, I want equals to 2 to the number equals to 3. So I will use square bracket to talk about 2 and 3, which 2 is in, 3 is in. If I use round bracket, means exclude. I don't have those 2 endpoints. Again, not include 2, not including 3. Okay, so let's have a look. So we have round bracket negative 2 to 3. Basically, I want to have a collection of x such that my x is in between 2 and 3. Okay, my x is in between 2 and 3. Not including 2, not including 3 because it's round bracket. So I will draw this on the number line as because it's round bracket, not including those 2 endpoints. So I will have this line. Okay, not including 2, not including 3. Okay, no negative 2, no negative 3. Okay, next one is square bracket. If you have square bracket 2 to 5, which means I want a collection of x such that 2 is included and 5 is included in between 2 and 5. So in between 2 and 5, you use closed circle to talk about that. In between 2 and 5. Next one is a mix of numbers, mix of brackets. Round brackets on the left, square bracket on the right. Okay, remember, left-hand side always needs to be the smallest number. Right-hand side always needs to be the largest number. I cannot write 4, -3. That not make sense, okay? So this one will be a collection of x such that x is in between -3 and 4, but not including -3, include -4. Include 4. So -3 here and 4 here. And I want a collection of those numbers, so it's in between that set. Okay, round open circle on the left, closed circle on the right. And next one, almost there. X, -2 to 0. I'll have -2 included, but 0 not included. Okay, so equals to -2, but less than 0. So -2 is there, we have closed circle, and we have 0 here, we have open circle. Okay, we need numbers in between -2 to 0. Okay, next 2 is important. If I want to only say this x is greater than 1, okay, only means that greater than 1. So I don't have 2 points to talk about that. Okay, I need to have a start point, I need to have a finish point. But now I want to say only things greater than 2. I don't have a finish point. So we use the symbol infinity. Okay, we use the symbol infinity. Try to learn how to draw infinity. Do not draw 8 for me on the exam, okay? So do not write 8. So it's a vertical side of 8, okay, so that side, 90 degrees rotate, 8. But they are the same size, 2 circles, okay? Do not draw really 8, smaller on the top and larger on the bottom. So we use 1 to infinity, means 1 to everything to the right. So it's a collection of x such that x is greater than 1. So greater than 1 means open circle on 1, but everything on the right. Okay, everything on the right. Okay, next one is 2 to infinity, but include 2. So it's x greater or equals to 2. Okay, x greater or equals to 2. Infinity must be on the right-hand side. Okay, must be on the right-hand side. Yes, that's the next thing I want to say. It's always round bracket. Okay, combined with infinity is always round. Which notation? No, in the set notation we don't talk about like infinity. We on top x greater than something. Okay, infinity is only used in the interval notation, not in the set notation. So x greater or equals to 2. We have 2, which is closed circle, and we have infinity to the side. And next to we have, we have to the right hand side, then we will have to the left hand side. So every number smaller than a number. So I will use negative infinity to represent the really negative number. So negative infinity is always on the left hand side. And same thing, we always have round bracket to combine with negative infinity. So negative infinity to -1, which means it's all the x numbers, x is smaller than -1. Okay, x is smaller than -1. We have -1 here and things smaller to that. Okay, you can see this is always round bracket. That's always round bracket. On the positive is always round bracket and always round bracket here. And x smaller, negative infinity to 0, which means all the x such that x is smaller equals to 0. So I will have 0 as closed circle and everything to the right. Okay, to the left, sorry. Everything to the left, which is x smaller equals to 0. 0 is the closed circle. Okay, we will finish here and I'll keep going tomorrow. Okay, I need